The improvement kata as a deliberate practice to develop scientific minds. And I wrote a sentence here to go along with that. The improvement kata being about a process of deliberate practice in order to develop more scientific thinking in groups of people who work together. And really a lot of the challenges we face require that we work together, whether it's in business, our family. Jeremiah Davis is here to talk about family, or politics or whatever. And that's essentially what the Toyota Kata research found out. I mean, picture the fellow in the red shirt there as being a good Toyota manager, essentially teaching a person through practice on real things how to solve problems and how to reach goals. That's essentially what we found. And that's what was so interesting about it. It's like, oh, it's not just those tools. There's actually a process going on here. Another way to put this is scientific thinking for everyone. Scientific thinking for everyone, I think it's an interesting idea. And I'd like to make just 3 points about that. Number one, we'd like to propose that scientific thinking is a life skill, not just a business professional skill, but a life skill. Assumptions that we naturally make as humans, and I think a key word to remember there is naturally. We don't even realize we make these assumptions, that perception is a clear lens, that what we see or hear is coming in unfiltered. Another assumption that we naturally make is that our reasoning is mostly under our conscious control. If I'm thinking something through, I'm thinking about it deliberately, consciously, I'm making a rational decision. As you probably know, what really happens is, it might be called brain illusions, right? That is, our brain receives a sensory input, and the unconscious mind instantly interprets it and builds an explanation, quickly filling in gaps without us realizing it. How many times have you, out of the corner of your eye, seen something and thought it was the cat sitting on the chair, there's the dog, or something like that, and when you turn to look at what you saw out of the corner of your eye, it's not what you thought it was. It's a jacket lying there or it's something else, right? It happens all the time. What's interesting about that is that our brain didn't say, there's something over there, I'm not sure what it is, need more information, hold tight. Instead, it immediately decides what that is. And that's that process in action, right? Now, don't let me give you the impression that that's necessarily all bad. We wouldn't be here today without that mechanism. We wouldn't survive without that mechanism. We see something out of the corner of our eye and we react. Just think about driving a car. If you consciously had to think about everything, all the input you're getting, and process that before you could do anything with it. Or you said, well, I think there's a car coming from the left there, and they may be running that stop sign, but I'm not sure yet. I think I'm going to wait and collect some data and think about that rationally. We wouldn't be here today. But on the other hand, it also causes us to make errors. So our unconscious predispositions, natural mental shortcuts, and beliefs influence how we see, think, and react. So it's a good thing, the large print giveth, but it also causes some problems. The small print taketh away. So just to demonstrate, and some of you may have seen this before, please read aloud what you see. Okay, one more time. Right? And now here the brain is helpful. Even though we're missing some data, the brain fills in the gaps, we can read this sentence. Right? Let's try it again. Please read aloud what you see. Right? And in this case, our brain fills in the blanks here, but in this case it's an error. Right? We feel pretty sure, but we're actually wrong. That's kind of what happens with these brain illusions. We feel pretty certain, we act on them, but we're wrong. Okay? Now the funny thing about this exercise, how many have already seen this exercise we just did? Quite a few of you. And I knew that. Let's go back and do it again. What do you see? Beth pronounced it correctly. It works even if you've seen it before. Your brain fills in the blanks. So a countermeasure to this natural bias that we have is scientific thinking. And scientific thinking, there's a lot on the internet. There's a lot of stuff out there about what is scientific thinking. Really, to me, it's essentially a routine of intentional coordination between what we think will happen, what actually happens, and learning from the difference, and using that learning to move forward. And you might recognize this as problematic because we feel bad when we get something wrong. We might even get in trouble if we get something wrong. But actually, the difference between what we expected to happen and what actually happened is the place where we can learn. So as we get started with Katacon, a premise is that scientific thinking, this process right here, is a skill not just for professional scientists, but an essential and widely applicable skill for everyone. It's what we like to call a meta skill. It's a skill that is universal. It is a skill that, as Beth Carrington likes to say, is content-free. If you learn this skill, you can apply it to almost anything that you're trying to pursue. Okay? All right, that's my first point. Scientific thinking as a life skill, as a premise for this conference. Number two, interesting, and this is something I've been thinking about and sort of observing. I interact more and more with teachers these days, and we haven't been teaching scientific thinking in a way that makes it a skill for every day. That's my opinion at this point, and I'd be interested in what you think. But I don't think we've been teaching in a way that takes scientific thinking and brings it into our everyday lives. We get introduced to the scientific method in school, at least here in the United States. These are stock photos, but I think they represent what most of us did. Actually, a couple of these aren't stock photos. And essentially, we get introduced to the scientific method as a systematic process to investigate and shed light on something that exists. There is a phenomenon. We study the phenomenon and do experiments to try to understand what's happening there. And that is the scientific approach that's used by professional scientists. So here's just a quick example. On the left is sort of the scientific method, if you will. There are a couple different ways to depict it. Observe a phenomenon and ask a question. Question, does water freeze faster on its own or with sugar added? Construct a hypothesis. I predict that water freezes slower if we add sugar to it. Test it via experiment, place 2 containers of water in the freezer, and check how fast they're freezing, and so on. These pictures were taken 2 weeks ago at a middle school science fair, and it's just a good example of what we're learning as middle school students. What do plants grow best in? There it is. Is your dominant side more sensitive to touch, or does color affect first impressions? And of course, the middle school science fair classic, can yogurt improve a dog's breath? My hat was off on that one. So I think there's some mismatch. The classic way of teaching scientific thinking is a great start, but it doesn't transfer to our daily life. These are pictures that are supposed to represent our daily lives at work, at home. Why? Rather than investigating and trying to understand like professional scientists, our work and personal lives involve pursuing complicated goals. I mean, just imagine going to your boss and saying in a meeting, you know, I've been studying how plants grow in different soils, and I'm learning a lot about, you know, how these things happen. We actually pursue goals as adults. So the improvement kata teaches scientific thinking, but for daily life. So we build on the good start with the classic scientific method, but to make it appropriate for us as normal human beings, not scientists in a lab, the improvement kata pattern adds a sense of direction. That is, it's a systematic process for trying to achieve something instead of just trying to understand something. I got to say, though, there's a bit of a problem here. The classic scientific method is sort of agnostic. You're just trying to understand something. When you add a direction in, like with the improvement kata, you can use it for nefarious purposes. It can be use it for good or you can use it for bad. So by adding direction in it, we do put a human desire element into it as opposed to just unbiased study of nature. Little caveat there. And again, a sense of direction, you know what it looks like, the improvement kata pattern. It's experimenting your way forward instead of trying to decide your way forward. We know that trying to decide your way forward means we're going to be relying on our bias, right? So we have a challenge, number one, with that challenge out there. Number two, we figure out where we are, what's the actual condition now. We establish a next target condition on the way to the challenge. And then there's a series of experiments that take place at the knowledge threshold. Okay, third point I'd like to make about scientific thinking is that it is by definition a learned skill. Because we have those natural unconscious mental mechanisms, that's a cat on the chair, oh no it's not, it's just my jacket, right? We have those natural mechanisms. It is by definition something you learn, it's not something you're born with. But how do you learn it? Acquiring new skill, mindset, and habits takes some practicing. Knowing is not enough. Here's a person reading. Reading is useful. Toyota Kata book may be useful, but that's not going to change anything in our mindset and behavior. Likewise, attending classes, good way to introduce things, attend a conference, but you're not actually going to change your mindset by listening to someone talk. It really takes daily or frequent practice. If you're going to practice, you need to have something to practice. Those are like routines or kata, at least for beginners. Generally, we need to do it with some coaching. If I practice and Wayne doesn't coach me, I'm going to practice my existing habits because those are the ones I automatically do. And finally, there has to be some sense of progress, some sense of mastery. I'm getting better at this. So those are some ingredients of changing how we think and act, or changing how we act and then think. So this has some significant implications. This slide has a lot of words. I apologize. But the fact that we learn the scientific way of thinking through practice means that you can't just drop the improvement kata pattern or any new way of thinking into an organization like a method, like a problem-solving method, and say, now go ahead and use this to solve problems. It requires a concurrent process of developing the necessary mindset in individuals. I'm sorry to say, we found no way to coach large groups of people at once. It's really a one-on-one thing. The coaching that I need is going to be different from the coaching that Bill needs, is going to be different from the coaching that Beth needs. We're all going to be at different places. So there's this concurrent process of developing the necessary scientific mindset in individuals through coach practice while the learners work on real goals. Fortunately, you can work on real goals. It's not like I'm going to practice for 10 years and then I'll become a productive member of the organization. So, what's new here? Number one, scientific thinking is not new. If you look it up, the scientific thinking as we know it today is about 400 years old. And if you broaden the definition of scientific thinking a little bit, you're back with the Greeks, and who knows, we don't have any records before that. Deliberate practice is not new. Anyone who has done anything with music and sports knows that those are things that have been around for a long time. However, I think combining these two things is at least somewhat unique. Taking the idea of scientific thinking as a meta skill and combining it with routines of deliberate practice is a pretty neat idea. And it means, I think, and maybe this is why we're here, it means we may have the opportunity to change the world ever so slightly. And maybe. Or your world, whether your world is your family or your business or just yourself. But we have the ability, by acquiring a scientific or a more scientific way of thinking, to change the world a little bit. And that's why we're excited to share what we're learning here at KataCon. All right, real quickly, I'd just like to do a quick kata recap. Most of you know this, I'm sure, so I'm not going to dwell on it at all, but I'd just like to kind of even out the playing field a little bit. A few key points to keep in mind during the Kata Summit. Number one, kata are practice routines. It's pretty simple. They're things you practice, structured routines you practice at the beginning so that their patterns kind of internalize. You don't practice them forever. Just a couple photos here. The photo on the left is kind of an odd device, right? It helps you hold your hands correctly for a golf swing. But it's a great example of a kata. Would you be using that for the rest of your golf career? So these are good examples of practice routines that get us going with a new skill or habit or mindset that we're trying to learn. Number two, the improvement kata is a model of working scientifically and pursuing goals. It has these 4 steps. We just talked about the 4 steps a minute ago. Anytime you do research, you have to create, or you generally create, a model of what you're observing. This is a model of what we observe to be the behavior of Toyota managers. Now, there's a great variation inside of Toyota managers, but by and large, we said they tend to do this, right? And George Box said all models are wrong. That includes this one. Some are useful, and I'm hoping that includes this one. But the key point we want to make about the improvement kata model is that each step of the improvement kata comes with practice routines. So if you publish a model, you can be sort of satisfied as a researcher and say, I published a great model from our research. And you can hope that people will take that model and do something with it to change their behavior. But as we're learning, of course, that's not going to happen. So what we have here is a group of practice routines for each step of the improvement kata that allow you to change your behavior. And that's kind of the key point with the improvement kata routines. There's also a coaching kata. We said coaching is very important. How does the coach need to behave? What does the coach need to do? And finally, second to finally, there is a learning progression. We have found no way around the practicing to learn how to do it. So you go from I'm aware of this to I can do it to I can teach it to others. Finally, The improvement kata pattern is used at all levels in an organization. We noticed it was picked up a little bit as sort of a problem-solving methodology that's used down in the organization, but that's not what we saw at Toyota. Yes, they practice it more overtly at that level in various ways, but once you've acquired this mindset, this way of thinking, it's not like after 10 years they say, now that you're an executive or a high-level manager, forget everything we taught you. We want you to have a new way of thinking and acting. If you've practiced a way of thinking and acting for 5, 10, 15 years, it's almost impossible to remove that. Now, the way it's applied at the higher levels in the organization may look differently. They have more strategic things they're working on. The experiments are much longer in cycle, but it is a pattern of thinking and acting that accompanies you throughout your career, at least in the Toyota organization.